My name is Dr. Gwen Martin. I am an instructor here at Ball State University, and we are going to go over graphs today. Before we start, let's define graph. Exactly what is a graph? A graph is a comparison of the quantifiable effects of an intervention on a behavior at various points in time of the study or experiment. It is a visual display of the relationships among and between a series of measurements and relevant variables. For me, a graph is a visual representation of the data, plain and simple. There are different types of graphs. You can have a pie graph, a bar graph. Applied behavior analysis typically uses line graphs. So that is what we are going to focus on today. We're going to look at graph titles, the y-axis, the x-axis, data points, data paths, phase change lines, phase labels or condition labels. You will hear phase and conditions be used interchangeably throughout this PowerPoint. And then the legend. For the y-axis and x-axis, we will look at the labels, and also for the data path, we will look at the labels. So let's start. In front of you on your screen, you have a withdrawal, an ABAB graph. This is a withdrawal design. If you're unfamiliar with this type of design, I encourage you to review the experimental design video as well as your text. So starting out at the top, you will have if you follow the arrow here, you will have your graph title. Your graph title is basically the title of the graph, plain and simple. It should reflect the data that has been graphed. It shouldn't be a paragraph. It shouldn't be, 10, 12 words. It should be short and simple and should let the reader know exactly what they're looking at. So for this one, the title is Inappropriate Comments During Health Class, short and simple. Your lines here are your y-axis, which is your vertical axis, and then your x-axis, again, if you follow the arrow on your screen, which is your horizontal axis. Your y-axis should reflect the data that is collected, the type of data that has been collected. So for this particular graph, frequency data was collected, and it is labeled numerically by frequency. You'll notice that each point on the y-axis line is equally distant from the other point. All points should be equidistant. It should start at 0, although some sources will tell you to start at -2. Typically, it should start at 0 and go up depending on the amount of data that was collected, the level of data that was collected. Again, this is frequency, but you could have duration, you could have rate, you could have percentage. So, for example, if you had percentage, instead of it being listed as 2, 4, 6, 8, 10, you might have 10%, 20%, 30%, 40%, and so forth. Also, this is listed in twos. This is numbered by twos. It doesn't have to be numbered by twos. It could be numbered by fives. It could be numbered as 1, 2, 3, 4, 5, 6, 7, 8, and so on. Again, how you number this depends on the data that was collected. If you have data that goes up to 100, say you did a frequency count of up and you have a data point that hit 100, it might be easier to list this by fives, or to number this by twos versus to go 1, 2, 3, 4, 5, 6, 7, 8 all the way up to 100. So that just depends on the amount of data and the type of data that was collected. Your x-axis reflects the session or the date. So if you have a label, here is your label. It should be centered on the x-axis, and likewise your y-axis label should be centered on your y-axis. If you label your x-axis as sessions, then it should be listed by sessions. So you see session 1, 2, 3, 4, 5, 6, and so forth. If you label it as days or dates, it should be listed by the date or the date. So you may have March 1st, March 2nd, March 3rd, March 4th, and so forth. And just like your y-axis, all of the points on the x-axis are equally distant from the other point. That's very important. And your y-axis and your x-axis should touch right here at the corner, which is where your 0, where your graph would start. Other lines on this graph are your phase change or your condition change lines. Each section here is a phase or a condition. The label above it is the condition or the phase label. It should be centered above the phase. The line that separates each phase or condition is your phase change or your condition change line. This line is typically dotted, although it can be solid. And I should also make a note that your y and x axes, the lines should be solid. Back to your phase change lines. These lines are typically dotted, but again, they can be solid, and they should separate the different conditions. You'll also notice a line here. Each circle here is a data point. Each data point represents the data that was collected during that session or on that date, and it corresponds with the y-axis as well as the x-axis. So for example, in session 1, the subject exhibited, let's see here, 12 inappropriate comments. So they counted 12 inappropriate comments. So on session 1, you have 12 comments, so your data point is there. In session 2, you had 10 comments, your data point is there, and so forth. This line that connects the data points, that's your data path. You'll notice that the data path does not cross the phase change line. Your data path should never cross your phase change line. This label right here is your data path label, and it should be, again, a very brief description or label of the data that was collected, which is inappropriate comments. So that's the behavior that was monitored, and then an arrow pointing to an early data point. So this one's pointed to the second data point, which is absolutely fine. And let's see here. You have the participant's name. Now, this is not a requirement, but you will see this on graphs. So it is important to go ahead and tell you about this particular component. So you have the name of the consumer right here in the bottom right-hand corner of the graph. Let's go to another graph so that I can show you a legend. So this right here, this is your legend. Again, you have your y-axis, you have your x-axis, you have your y-axis label, follow the arrow on your screen. You have your y-axis label, I want to make sure I said that correctly. And you have your x-axis label here. You've got your data points, you've got your line connecting the data points, which is your data path. You'll notice that there's no baseline, intervention, baseline, or intervention. This is one big, I guess, condition or one big phase. So there's no phase change line. You have your graph title here. Going back to the data points, you'll notice that the data points are different shapes. So you have triangles, diamonds, squares, small squares. When you have different shaped data points, it's important to have a legend to tell the reader exactly what each data point represents. It would be, the graph would be pretty muddled if you had a data path label for each data path. You would have 4 on here. So rather than doing that, it's better to just have a legend that just shows what each data point represents. And as you can see, this is an alternating treatment design. you have 4 conditions here, or 4 treatments going on at the same time. So because this is all in the same phase, it's all going on at the same time, it's best to have that legend to tell what each data point represents. So those are the basic components of your line graph. For this course, for 611, make sure you have each of the required components in your graphs that you submit. Now, if you submit a withdrawal, if you do a withdrawal design and you submit an ABAB graph, well, you probably won't need a legend because you're only going to have one data point shape. But if you do an alternating treatment design and you have multiple treatments going on simultaneously, then it may be wise to have a legend. So just make sure you have each of the components that's required for the graph for the type of experimental design that you have chosen. Additional components of a line graph, I just want to briefly talk about trend, variability versus stability in your data, and then the minimum number of data points, because these are also important components. This particular graph, one, doesn't have everything that it should have, so please don't use this as an example for how to do a graph. I just basically want you to look at the lines so that you can get an idea of trend. So as you can see, this is an increasing trend. This is a decreasing trend. I want you to look at this graph too. As you see here, this is a decreasing trend. This is an increasing trend. So you'll notice that the line doesn't have to be exactly straight, but if we were to draw a line through the data points to represent the direction of the data, you will see that it's increasing. So if we go back to the previous graph, if you were to draw that line through the data points, you would see that while the data points are not in a straight line, you will see that it is an increasing trend, and this is a decreasing trend. Also looking at stability versus variability. Stability in your data means that your data is kind of centering around a particular level in your graph. You can see that this data is pretty stable. Whereas if you look at this one, it's variable. You can see that it's high, it's low, it's in the middle, goes back to low, jumps back up high. So the data is all over the place. It's unstable, and there is no trend in this particular case. Whereas here it is stable, and whereas in this one, you not only is it stable, but there's a decreasing trend. And the same with this one. Not only in this graph is the data stable, but it's an increasing trend. So when you discuss your graph or your data in your assignments in 611, you'll want to talk about your data in this manner. You want to say the data was stable, the data was unstable. The data showed a decreasing trend. You want to be able to describe and discuss your data using those terms. Make sure I didn't miss anything. Oh, minimum number of data points. Let's go back to the previous graphs. As you can see in this graph, there are 5 data points. 1, 2, 3, 4, 5. When you are collecting data and graphing your data, you want to have at least 5 data points. Now, there are some sources that say 3 data points is sufficient. Anything below 3 is unacceptable. For this course, 5 data points at a minimum per phase or per condition. So I hope this was helpful in learning about graphs. As always, if you have any questions or would like to discuss any of the information further, please do not hesitate to contact your instructor. Here is the reference, which is your Cooper book, your textbook for this course. There are some additional videos on graphs in this course. I encourage you to view those also. Thank you for watching and have a great day.